Thanks for joining us. Today we'll walk you through how we partnered with Westinghouse's nuclear fuel team to transform their production planning and scheduling using a Simio-powered digital twin. We will share the key lessons and results from that journey. First, we'll provide an overview of the Westinghouse Electric Company and Mosentech. For those not familiar with the nuclear fuel assembly, we'll provide an overview of the technology, the manufacturing process, and the components involved. For Westinghouse specifically, we'd like to discuss in more detail the complex global supply chain. Our client, Brad Parker, Director of Global Manufacturing and Material Planning, will comment about the planning process at Westinghouse, current and future vision. My colleague, Gerda Trollop, Senior Consultant with Mosentech, will demonstrate some of the models and reports we generated. Finally, we want to share some lessons learned and best practices for similar implementations. Westinghouse is the world's leading supplier of safe, innovative nuclear technology. Founded in 1886 by George Westinghouse to prove the power of alternating current, the company has spent nearly 140 years redefining how the world generates and uses electricity. Their nuclear reactors are operating on multiple continents, with more installations approved in recent years. That same innovation drive now underpins the factory-built eVinci microreactor, which cleared a key US licensing milestone in March 2025. Through simultaneous progress on gigawatt-scale units, advanced fuels, and transportable microreactors, the company shows it can still push the frontier across every layer of nuclear technology. In this slide, we see Westinghouse's vision and values, which highlight the power of collaboration in advancing technology and services for a clean, carbon-free future. The central theme, together, emphasizes teamwork and unity in driving this vision forward. Key values include customer focus and innovation, speed and passion to win, and teamwork and accountability, which align with the company's goals of being at the forefront of technology advancement. At the bottom, the foundational principles of safety, quality, integrity, and trust reinforce Westinghouse's commitment to maintaining the highest ethical standards and operational excellence in everything they do. The company employs more than 11,000 people across 21 countries, underscoring its international reach. It operates with 5 distinct business units: long-term operations, outage and maintenance services, nuclear fuel, energy systems, and the innovative eVinci microreactor technologies. With over 90 facilities worldwide, Westinghouse's technology plays a pivotal role in generating nearly 50% of the world's nuclear power, emphasizing its critical role in the global energy landscape. Today, our focus is on the nuclear fuel business unit. Westinghouse is a complete fuel supplier, handling everything from development and manufacturing to core engineering, safety analysis, and fuel component manufacturing. Westinghouse offers 4 key fuel types. Pressurized water reactor is the most common type of nuclear reactor, using pressurized water as both a coolant and a heat exchanger. It is characterized by its safety features and reliability. In a boiling water reactor, or BWR, water is boiled directly within the reactor vessel to produce steam, which then drives the turbine. This design is simpler, but can be less efficient than PWR. Russia developed a type of PWR reactor, VVER, or water-water energetic reactor. This one operates similarly, but with differences in design, primarily in the pressure and temperature limits of the coolant. Finally, advanced gas reactor, or AGR, uses carbon dioxide as the coolant and graphite as the moderator, with the core being heated by nuclear fission. It offers higher thermal efficiency and is commonly used for experimental or future energy designs. Again, Westinghouse provides all components necessary for nuclear fuel, including development, manufacturing, and safety analysis, and have fuel manufacturing facilities located globally in the United States, United Kingdom, and Sweden. The corporate headquarters are located in Cranberry Township, Pennsylvania, with a global presence of customers. For today's discussion, as highlighted by the red circles, Mosentech has been fortunate to collaborate with Westinghouse on Simio implementation projects across their key nuclear fuel and parts facilities. So where does Mosentech fit in? We are a consulting services company focused on utilizing modeling and simulation technology to make informed decisions. With a 14+ year track record and consultants with even longer personal experience in applying modeling and simulation, We're fortunate to work across a broad spectrum of industries. Return clients include very well-known brands and others you may have never heard of, but serving a key part of everyday life. We have a saying, one day we might be flipping burgers for a quick service restaurant, and another you're working on rocket engines for space exploration. Our simulation work truly provides an opportunity to learn about a wide range of businesses, and more so, being able to guide our clients to know more about their own business continues to be really fulfilling. We're proud to call Westinghouse one of our many long-standing clients and appreciate the opportunity to share with you today some of the work we've done with them. I'm now going to play a brief video tour of the Columbia, South Carolina facility. Watch as uranium dioxide powder moves through each step of production, emerging as a zirconium alloy fuel assembly, ready for shipment to the customer.
At Westinghouse, what we do matters. We power the world and provide enough energy to meet 10% of the United States' electrical needs. Our nuclear fuel is produced here at the Columbia Fuel Fabrication Facility.
The product that we make here at Columbia, both the fuel and components, are shipped domestically to the United States to many customers all over the United States, and then also internationally.
The Columbia plant sits on more than 1,000 acres. Inside, the plant is divided into two main sections, the chemical side, where uranium is processed, and the mechanical side, where assemblies are fabricated. Enriched uranium is shipped to the chemical side of the plant. Here, it is converted into a gas and then into a powder. The uranium powder is tested to ensure it meets exacting specifications.
In the chem lab, we test the quality of the pellets and the powders. They come off the lines, and we have to make sure that the quality is good enough for them to move on and put into rods.
The uranium powder is pressed into small pellets, each one about a half-inch long and holding as much energy as a ton of coal. Once pressed into shape, the pellets are fed into a high-temperature furnace that increases their density and converts them into a hard ceramic.
And then we grind them down to the proper diameter, and then we inspect it before it goes out to be loaded in the rods.
There are several production lines running at once, and control room operators monitor critical steps across the lines to ensure quality and safety.
Control room purpose is making sure all lines are running by each parameter that's set by engineers. So you have different parameters set for each line.
In the rod assembly area, pallets are loaded into tubes that are manufactured at a separate Westinghouse facility in Pennsylvania. The tubes are pressurized with helium and sealed, and the completed fuel rods move to the mechanical side of the plant.
Once it comes through the wall, it's now enclosed in a rod. It's encapsulated, and it's not just one pellet, but a series of pellets. And that rod, it gets treated. The ends get closed up, it gets polished, hardened on the tip.
Fuel rods are mounted into an assembly, the structure that holds the rods in place. A typical assembly can house 76,000 fuel pellets. Assemblies are manufactured on site using human skills and robotic technology. Once completed, assemblies are washed, inspected, and packed for shipping. At Westinghouse, what we do matters. We power the world.
The video you're about to watch highlights key components that make up a boiling water reactor, or BWR, fuel assembly. BWRs are just one of several types of nuclear fuel assemblies manufactured by Westinghouse. The video focuses on the major materials used in the top, middle, and bottom sections of the assembly. In both manufacturing and planning, we differentiate between nuclear and non-nuclear materials. Nuclear components include fuel rods, pellets, and their composite structures. Non-nuclear or mechanical components form the structural framework that supports the fuel rods. In the case of Westinghouse models, we concentrate on the manufacturing aspects within the facilities. The Simio model architecture identifies which materials are needed for a fuel assembly and triggers their production and consumption based on a detailed bill of materials. Each material type follows a specific manufacturing route, which allocates the necessary resources after consuming the required input materials. The model also considers inventory levels and work in progress before starting any production. To account for purchased materials, the model includes expected lead times for each item.
The planning process at Westinghouse, previously, we managed this through 5 separate sites, 5 different planning groups, all operating independently. A majority of it in Excel, with no integration, no constraint between. Manually entered spreadsheets, meaning that when we created the master schedule for 18 months to 2 years, what would happen then is if there was any scenarios or if there was a change, it would take us up to a week to be able to assess what that change was. And then each area would then flow down from that to allow it to be a final answer as could we do it or not. With the implementation of Simio, what we've been able to do is make these decisions a lot quicker. The simulation model can run and we can change parameters, as you know, in Simio, based off the tables, based off the demand data, and run a simulation to assess the impact. But not only that, it is an integrated schedule for all areas to allow us to make sure that we don't have gaps in our analysis. This has obviously vastly improved our ability to do what-if scenarios, to respond quicker to customer requests, unplanned outages, or any combination, to give the business a better forecast of where we have constraints, where we need to improve, or what the impacts will be to other customers. For example, should we decide that we need to prioritize this over customer X?
Thanks for that background, Brad. Curious if you mind commenting on your selection of Simio as the solution for Westinghouse.
The flexibility, the ability to add, take away. Other models that I looked at seemed to be more the structure of it, in terms it was almost like hard-coded, which made amendment difficult. You shall do it this way. Not, okay, we can be flexible enough to make it fit your process, not your process has to change to reflect our way of doing it. Adding to the scenario building with the complexity across 5 sites, to do that across 5 sites, and you'll see on the next slide how everything is integrated with a vertical supply chain. It could take up to a month for us to do a high-level change at the Columbia facility to assess the impact on the WZ facility, which is at the bottom of the vertical supply chain, which would mean that if WZ could not do it, we'd have to start all over again or do a partial assessment, which would not give us the full visibility of the impact of the change we are proposing.
This slide presents a high-level overview of the global Westinghouse supply chain, highlighting the interdependencies across various sites. Materials are produced at different locations and must be transported to the appropriate consumption sites to meet contractual commitments with both internal and external customers. These commitments are often tied to key performance indicators such as core loading plans, customer delivery dates, and/or contractual delivery dates. For most sites, Westinghouse utilizes Simio's planning and scheduling tools indicated by the green tick marks, while a few locations have been analyzed through independent project studies also utilizing Simio, such as the pelleting automation and eVinci projects. These models help ensure that each site can deliver components or fuel assemblies on time by generating detailed production schedules tailored to meet delivery requirements across the supply chain. At Motion we follow a proven process for deploying simulation models, a process we also use to implement digital twins at the Westinghouse sites. First, the functional requirements specification. We begin by developing a detailed specification document that outlines the system to be modeled, the modeling approach, and the required inputs and outputs. This ensures alignment on scope and expectations from the outset. Then, phased model development. Our modeling approach is iterative. We build the model in phases, enabling the customer to see a working end-to-end version early on in the process. With each iteration, more detail is added, allowing for flexible adjustments and informed decision-making throughout the development cycle. Verification. This is the formal process of testing the model to ensure it meets the specifications and it performs as intended. Verification confirms that the model behaves according to the design and logic outlined in the requirements. Data collection and ETL. Because we emphasize a strong specification phase, data requirements are clearly defined before development begins. This enables parallel workflows. Data collection and transformation can proceed alongside model construction, improving efficiency. Validation. Validation ensures the model accurately reflects the real-world system behavior. While verification checks internal logic, validation evaluates the model's outputs and assumptions holistically, confirming the full model ecosystem, the code, assumptions, and input data behaves like the actual system. Then analysis. Through model analysis, customers gain insights into system performance and behavior. This understanding typically deepens throughout the development and validation phases, enabling more informed decision. Integration and change management. At this stage, we help clients apply the model effectively to drive business improvements. For example, Westinghouse now uses its models regularly to inform production planning and scheduling. Ongoing analysis and support. In the final phase, customers continue to use the model for strategic, tactical, and operational decision-making. We provide formal training and model handoff and remain available to offer support or implement updates as needs evolve.
Thank you, Gerda. To roll out these digital twins at Westinghouse, we followed a milestone-based approach and roadmap. We couldn't wait for all data to be available or all systems to be updated. Otherwise, one will end up forever getting ready to be ready. Instead, we identified an initial milestone to make work with the data and information at hand. This effort provides a baseline functionality with standardized scheduling solution across plants and replacing or augmenting current spreadsheet planning outputs with Simio-generated outputs. More so, this effort truly identifies data gaps, capability gaps, and opportunities for automation. A subsequent milestone by site and in some cases at the corporate level was shared enterprise solutions, focus on eliminating manual data feeds and replacing them with automated workflows. One key benefit that came to light here was identifying a single source of truth for certain key data points, for instance demand. If it's not captured and reported in SAP or SAP, it wouldn't get planned for. Where applicable, additional depth or breadth of the planned scheduling models were also addressed. Various sites at Westinghouse are at different levels of maturity with regards to milestone 3. This is where digital twin solutions serve strategic long-term planning, master planning, and even detailed planning. Each of these applications have a key prerequisite of either standardized source data towards a fully automated data pipeline or more granular near real-time data to represent accurate current state. This slide illustrates the flow of data across various systems that support capacity planning and scheduling in a manufacturing environment, in this case Westinghouse. Data originates from multiple sources. SAP provides key information about resources, materials, bill of materials or BOMs, routings, orders, and inventory. The MES contributes real-time data, including equipment status, work in progress, WIP, and current tasks. SAP Ariba handles data related to replenishment parameters, lead times, and reorder quantities. Excel may include labor qualifications, process data, and staff availability, amongst others. Not illustrated on this schematic is an ETL functionality, or extract, transform, and load, that move data from various sources into a central data warehouse or database. For Westinghouse, we fast-tracked an Excel Power Query-based approach as an interim solution for rapid discovery. This data feeds into Simio, which processes it to produce capacity feasible planning and scheduling. Specifically, Simio supports critical functions like master production scheduling, MPS, resource capacity planning, material requirements planning, and detailed planning. The output from Simio includes manufacturing orders, planned orders, inventory levels, task lists, resource assignments, and material requirements. This ensures that operations are aligned with the availability of resources and materials. This slide emphasizes the importance of data governance, ensuring the data is standardized, timely, and accurate. It also highlights the need for both static enterprise data to create the model and dynamic system data to initialize and operate the model. This data-driven approach follows a predictive and prescriptive methodology to forecast potential scenarios and guide optimal decision-making, ultimately ensuring plan adherence and improved operational efficiency.
For us, system understanding and definition begins with the development of a detailed functional design specification, as mentioned earlier. We believe that if you can't clearly describe a system, you can't model it effectively. This document outlines both the real-world system and the intended model, using diagrams and narrative to convey the necessary level of detail. The functional design specification is reviewed and approved by the client, ideally before model development begins. However, it remains a living document, evolving alongside the model as new insights emerge. Clients at the Vastra site have expressed that they find this document especially valuable as it provides a single, comprehensive reference that captures the entire process from start to finish. To build a true digital twin that extracts live data and runs a scheduling plan, it was crucial to ensure the right data came from the right sources at the right time. To prepare the data for import, we developed extract, transform, and load, or ETL, solutions to clean and integrate the raw data. This was an iterative process involving on-site stakeholders with many adjustments made along the way. Currently, the data import is Excel query-based, which is not the final enterprise version, but works well for the current stage due to its flexibility and quick implementation. Throughout model development, we made extensive use of error logs to provide feedback to the clients, helping them clean and standardize their data. The result of the ETL process is shown in this slide. It illustrates the model-ready data schema within Simio, highlighting the relationships between the various data tables. The models we created are fully data-driven, meaning they rely on real-time, dynamic data inputs. This approach provides users with the flexibility to quickly refresh and generate new plans that span multiple years. What previously took weeks can now be accomplished in just a few hours, enabling faster decision-making and more efficient planning processes. These are some of the key dashboards available after simulation run. For client confidentiality, the values have been desensitized and may appear as gibberish on the slide. These dashboards were instrumental during the verification and validation stages of the projects, providing insights into system behavior and performance. Production performance. After each run, users can see a comprehensive overview of production performance. This includes a comparison of the results from the generated plan to actual operational or contractual targets. This feature helps assess whether production goals are being met and highlights any discrepancies that needs to be addressed. The flow of materials. This dashboard visualizes the flow of materials throughout the production process, ensuring it matches the bill of materials. This is crucial for tracking material consumption and verifying that the right materials are being used at each stage of production. Throughput analysis. Detailed throughput data can be analyzed by area, providing a clear view of how materials and resources are performing across different parts of the facility. These reports are shared with area managers and planners to ensure coordination between departments, so everyone is aligned towards the same production plan. It also helps identify areas that may require adjustments to improve efficiency. Resource utilization. Resource utilization statistics are displayed, offering insights into how effectively resources, such as machines and labor, are being used. This data is key for identifying bottlenecks within the system, which could indicate areas where production is being slowed down. It also helps prioritize where capital expenditure should be applied, whether for equipment upgrades, additional resources, or process improvements. The resource Gantt chart. This is one of the most widely used dashboards at Westinghouse. It provides a high-level view of the system, displaying how sales orders, color-coded for easy identification, move through the various manufacturing processes within the facility. This chart helps track the status of each order and offers a visual representation of the entire production timeline, making it easier to identify potential delays or areas that require attention.
Implementing a digital twin can be challenging due to several common pitfalls. These include data issues like missing, incorrect, or poorly formatted information, which can undermine the model's accuracy. Our advice is to make sure you understand the source of the data and how it was measured. Stakeholder engagement is critical, as lack of buy-in or misaligned expectations can lead to delays or scope creep. Communication and transparency is key here. Make sure you engage your stakeholders from the beginning of the project and throughout, rather than presenting them with a solution at the end. Additionally, a deep understanding of the system is essential. We have a saying that if you cannot explain it, you cannot model it. This supports what Gerda shared related to the importance of functional specifications and process diagrams. You may have to coordinate with different subject matter experts across the organization to truly understand the system. Simulation projects have resulted in different departments sitting around the same conference table for the first time, understanding how their own area impacts another. Keep in mind current and future state of operations to correctly represent the system and possible model levers. Once you do start getting results from the model, be sure to be in a position to explain cause and effect of the different results observed. Lastly, model development can suffer from scope creep, time constraints, debugging complexities, or the use of the wrong tools, all of which can impact the success of the digital twin implementation. Have a strong project management add-on, yet allow for variability and adjustments in the project as needed. We are, after all, in the business of discovery and making sense of complex systems.
So for Westinghouse going forward, we have rolled out what I would consider the basic Simio simulation software. Now the future holds the opportunity to expand the utilization. We are focused on nuclear fuel. However, we are starting to see other parts of the business show interest. Vinci is one example. But how we document and future utilize this with the functionality we've not even touched on yet is where we will be trying to take the Westinghouse organization and the utilization of the Simio solution.
In closure, on behalf of Mosemtech, thank you to Westinghouse for the opportunity to closely work together over the last several years. Thank you for this opportunity to share a brief glimpse into the work we've done together. Finally, thank you to Simio for the opportunity to represent here at Simio Sync 2025. We welcome questions from the attendees, and where we are not able to address your question here, please reach out by email or find our contact details on the respective websites.
Hi, well, thank you very much. That was a great presentation, and thanks to Brad from Westinghouse. It's a long time since we started the first functional requirements specification there at Columbia, and I'm very happy that we're at this point where you can share, what you guys have done over the last, months and years. Also, thanks to the Mosentech team there, Martin and Gerda. They're one of our top partners globally, and as an example, this work at Westinghouse. All right, I think let's see if there's some questions. The first question: has this program across different sites in Westinghouse sort of changed the approach to planning? And I think, Brad, this should go to your side. You mentioned that it was sort of this slightly dysfunctional Excel and so forth. Perhaps just some additional thoughts around this.
Yeah, so the way that we've changed our approach, as you can imagine, with 5 sites doing it individually, we have in the past tried to centralize the planning function. And my role now is pretty much the central planning function. That's what I run. Before Simio, it was almost, to be honest, impossible. You've got 5 sites with 5 different planning groups, all going in Excel. So in order for you to add value as a central group, you had to go and ask each individual site, what you're doing, send me your file, show me this, which kind of negated the benefit of it. So with the Simio implementation, in effect, my team runs Simio. So I can access every model from every site. So being able to see, okay, what does this mean? What's your schedule look like now? Or I can see this is going to be late here. Does that impact? What impact? Scenario build. It has allowed us an integrated planning function, which previously we struggled with as we had the Excel-based different drives, different ways of doing it, trying to understand how people used Excel. As you know, there's several thousand ways you can use Excel, and how often it was maintained made it difficult to centralize.
Very good. No, I mean that is a huge challenge, to get people to work as sort of one team across sites, because people get used to their own silos, right? And their way of working. So I'm not sure, Martin or Gerda, if you want to add to this.
Yeah, good morning, Garrett. I think we've truly from the outside as well seen what Brad has mentioned is so that integrated. I think we to the demand point were Excel files and emails and so many sources of demand feeding some of these, and I think the solution here with a centralized Simio under the covers, but the simulation-based planning forced it, like you said there. Some of them you have to put the hammer down, and there's single source of truth for some of the data inputs, and then they're starting to see those dependencies in between. So again, separating it, like you said, from silos, individual people doing planning, each with their separate set of information, to now combining it and seeing a sort of transparency across the different sites.
Okay. Very good. All right, let's see the next question. Yeah, so what would you do differently if you had to start over knowing what you know now? So this is a bit of a tricky one, right? The hindsight is always 2020, but I think it's just sort of what did you learn? Would you go more detail, less detail, focus more on data? What are things that if you can start again when we started at Columbia, a few years ago, what would you change if anything?
Yeah, so I think the key things that I would have done differently, first of all, is data. Understanding, it has been a long journey. It has, but a lot of it has been tied to findings on data discrepancy. Mosem Tech with the ETL has helped, so that has allowed us to implement quicker, obviously recognizing those issues. What I found is that the data gaps slow your Simio implementation when you're finding the issues in Simio. And it still plagues us today, to be honest. You can imagine if you do a model run, you think the data is right and it's not, you have to rerun it again. So it delays your response. So I think a bit more with what we know now, if we had done more in the data mapping to say these are the discrepancies up front, I wouldn't change the fact that we went ahead and used ETL, because to Martin's point earlier, you'd never implement. If you were waiting for perfect data, you'd never get there. But I think we could have gone in a bit more with our eyes open to what extent the data needs to be managed, what is not collating in the same way. We're reporting from 3 or 4 different systems. So if those are not aligned, which is what we found, that's a challenge, yeah. And you wonder why you struggle in planning when you've got 4 systems telling you a different number. It doesn't work well. So that's one critical thing. I think the other thing as well is I was strongly supported by Westinghouse. You know what I mean? I think one thing I will say that you must have when you embark on this journey is not only support up front from senior management, but that has to continue. It's not going to be perfect overnight. And a lot of people expect, well, we just click a button and it works. It's unrealistic. So I have been lucky that I've had that support for this duration, and I think historically where I've worked on not Simio simulation software, but other things, it can be abandoned because it's like, well, we don't want to keep trying this. It takes a time for this to be implemented. But on the flip side of that, you need dedicated resources. In effect, at times, I was managing 3 implementations at 3 sites on my own. So that slows down the implementation. But if you have dedicated resources, you can manage it. So I would say, yeah, data and resource allocation from the site, your business, and again, key resources, not just warm bodies. The people who know the process, the people who know stuff have to be involved. Because ultimately, if you're not getting that and you don't understand the process and you implement, you're going back again. Because you'll go and run it and say, that's not what we do. Well, that's what we were told. So, again, you're doing these iterations, which potentially you could avoid if you had the key knowledge in there.
Yeah. No, I think that's excellent points, Brad. The data one, I think we find that customers are often even surprised by how incongruent the data between systems really are, right? Because the data are typically used in silos, they think that is better than what it is. But when you bring it into the digital twin, it explodes, right? Then you really see the inconsistencies. So
yeah,
very good. All right. Is next question, please? Are you using Simio portal for Westinghouse? And if so, how's it been deployed to allow stakeholder access, right? So, always Simio or simulation was typically used to give an answer. But with portal, the opportunity is there to make it available to a broader stakeholder group. So, I don't know, Brad, Martin, who wants to take a stake? Perhaps Brad, you can start, and Martin, you can fill in.
I can start. The portal is something when I talked about expansion of the utilization of Simio, it is something we need to look at. To be honest, at the moment, we're still we're stabilizing the utilization of Simio as we've got it. You can talk to it, but I almost want it stable before we start saying we're going to put it in the portal, because we're still adjusting things occasionally. And then it's what information you put into the portal. There are some obviously hurdles we'd have to get through at times with our restrictive nature of the data and how, security. So, we'd have to go through that as well. But it is something we want to look at. But again, I want to make sure that we are fully stable, the models are set, because we, Gerda and Martin spend a lot of time in the models in the back of it, doing logic changes still. As we discover things, we talk about what we call the perfect storm. Everything works until this one thing happens, and all of a sudden it's like, where did that come from? And then we have to go and find it. And we say, well, we've never seen that before. So again, that's why I think the portal is a future, but not necessarily right now.
Okay. All right. Martin?
Yes, as Brad said, so primarily or across the sites, the deployment right now is desktop based. Brad mentioned so central. There's a handful of people that have access. Brad had some help with other team members running specific sites, but they're all desktop based right now. There was a initiative at Blairsville where there's actually a Westinghouse portal installed. It's one of the earlier versions of portal. Back then, looked at some of the capabilities in refreshing data automatically. So take away some of the assumptions of some of the still today manual cleanup of certain data points. So eliminating some of those, and then testing scheduled runs. So come into the office on Monday morning and the run's already done. Then starting it. And then same thing on distributing results. So there's been some testing on that stage, but not yet on a production level. Like Brad said, I think the Westinghouse focus is on data accuracy, where rightfully it should be. And then I think there's a natural progression there, opportunity to go to Simio portal. Mozambique, we have the next gen, I think was the code word for it, next gen portal. And on the side, we'll keep doing some testing so we can work with Westinghouse and Brad and team to say, yeah, we're ready now. Let's use this and apply this portal solution, because again, it can help potentially with some of the distribution. Right now, the data, as Gerda shared there, the data is being distributed, sort of internally, obviously in the planning team within dashboards and log files, and then there's some integration and feedback to other systems. But again, circle back. Right now, it's desktop based, and on the roadmap, I think there's definitely opportunity as it matures to go to portal.
Yeah, and I think it makes a lot of sense. The last thing you want to do is distribute bad results, right? It's always nice to get information in more people's hands as soon as possible, but you also don't want to, put the wrong results in their hands. But it does get that larger, as Brad said, larger stakeholder involvement in the project, the more people can, benefit from it. So, right, the next question there is, how quickly can a planner, Westinghouse personnel, adjust the bill of material, tables, other relevant data themselves without sort of key consultant intervention? I think, Gerda, you spoke about the data tables, the data driven. So perhaps, what are your sense on that?
Yeah, so at this stage, the Westinghouse personnel or planners, they don't need any intervention from Mozambique side to assist with that. They can update all of their tables and everything on themselves and run the plans. Typically, they only contact us when the results look strange and they can't make sense of that. And then we kind of double click in terms of, what's going on. And I think it's there's a split between, this is the data input that, we need to fix. And then sometimes it is, we need the combination of the data was never before seen. And then we have to adjust within the model. I'm not sure exactly about the percentage of times that we need to intervene versus how many times they do runs without us having to intervene, because we don't know about that. So I don't know if Brad can maybe comment on that afterwards, but we do get contacted if they want new dashboards, or they want to change something in the dashboards. Then we are contacted and we assist with that. And then theoretically, we should only, need to be, if the data is fine and all the combinations of the runs have been tested, theoretically, we should only be contacted if the system changes, if new routes are required or new products are being planned. But Westinghouse theoretically should completely be able to run this model on their own and get the results.
Okay. Brad, any comment?
Yeah, to Gerda's point, we change data all the time in it. That's part of the benefit of Simio. That's the what if scenarios. The way it's been structured in the tables by Mosentech does allow us to adjust process times. So again, part of the reason for the choice of Simio is that we can change things without needing to go and approach a programmer to go and say, oh, well, I need to change this in source coding or whatever it may be. Yeah, and I think, it's back to that data point. When we get where we have to engage with Mosentech is because we're not sure if it's data or logic. If the data was always good, then we'd know that Gerda, I need it because it's logic. But that's what can increase the amount of time that we need with Mosentech because we can't find stuff. We've been using it for a while now. Martin will probably be proud of me. I'll see error message and actually be able to understand what I have to go and do or what it is. So again, the key is getting users in it all the time, because you will see repeat error messages and which table it is. We even have listing now telling us which table and which data source it's saying is wrong. So that allows us to fix a lot on our own. So yeah, I think, I do approach Mosentech, sometimes I think Gerda misses me, so I'll email her occasionally. But, yeah, it is the benefit that all the tables are there. We have the ETL. We can correct a lot of the things that we find generally ourselves.
Okay. Very good. Very good. I think that's the beauty of the digital twin, right? That sort of data generated driven environment where most of the change you can affect through data, but as you said, if the data is wrong, then it's an issue. All right, perhaps the next question there, are there plans to feed data and planning information back into the core ERPMS interface to avoid tool switching? I mean tools, I assume software tools. So I think, Martin, you discussed the information coming from SAP, Ignition, Ariba, and so forth. Sort of any sort of sense, Martin, in feeding information back into SAP?
Yeah, so it is actually being done at different levels of detail. Brad can fill in some of the details there, but so yes, we do feed information back. For instance, I know there's a specific report or a log file that we set up, provide in a format that they can import it or feed it back into SAP planned orders. The planned orders populate back into SAP. And again, on another refresh, those SAP planned orders will be replaced with the new run, the new plan. And then those orders, again, back to what Brad mentioned earlier, ends up being feeding demand and information in the subsequent system in the supply chain. There's a few other initiatives. More recently, there's one using the model and the outputs from the model to feed into financial planning or financial reporting that the team needs to do or a different department needs to do. So, for instance, without going into details, but monthly clearances and month-end working process inventories, get the model data from. Or they get those inventory numbers separate from somebody else doing their own planning and projection of what it will look like. Simio is doing it right now as part of the planning function. Export and get that data and apply the financial metrics to it, and that supports that initiative as well. And then as Gerda illustrated, various dashboards and look and feel inside the Simio tool that the planners use, and then like I mentioned, a number of log files and other reports, some of them not flashy enough to show on a presentation. It's just data, but those things being shared with relevant people, whatever type of data or information they need.
Okay, well, that's excellent news to close the loop, right? That's where you want to go at the end of the day. as at some point, I think, Brad, you would want to be as hands-off as possible, right? And have this whole thing run, lights out, as they say. But that's not as simple as it sounds. So,
yeah, it's a vision to get there.
Yeah, it's a vision, and it's a good one.
Yes.
I think let's see if we can take one more question here. We're sort of running at the end of time. So what change? Oh yeah, this is an interesting one. What change management efforts, if any, were required and perhaps still ongoing as part of this change in approach? Right, we always see with other customers as well that this is also a key part. So I don't know, Brad, how this affected, probably still ongoing at Westinghouse.
Yeah, so obviously with the organizational restructuring, we've already mentioned that, we have the Global Central Planning Group. I think the ongoing is managing the expectation of what Simio can and cannot do. We talked about scope creep. Yeah, there's always scope creep. Everyone sees the Simio tool and says, oh, can it do this? Can it do this? Can it do this? And I've been taught by Martin and everyone else that, sure, if the data's there. So, there's a lot of managing that expectation that, oh, well, Simio's here now. It tells us everything we need to know. We want to use it on the shop floor. Is one of the things we're constantly asked. And yeah, we can do that. However, is the data available to support that? If you want to do a daily management of what line runs what, then I need to know exactly if that equipment's up or down. When's it going to come back? If it's not, who's working today? If it's a manpower resource, and that trying to manage that expectation has been, is an ongoing. The other key one, which we find, is that everyone wants to look at it and say, well, Simio's not. So we have our local production planners who may still maintain a short-term schedule in Excel. They follow our sequence, but they may do some adjustments for things like unplanned people not being available or some intricacy where they say, we don't usually want to do this. So a lot of effort is spent explaining the change management process of Simio is here to do what we expect as a standard process. We run this line, we do this, we only run this on 2 lines. If we end up talking a lot more about, to Mike's point earlier, when you're in these discussions with planners or whoever, as soon as I start hearing the words sometimes, occasionally, that's where it gets very difficult. And we've kind of managed the change of where they say, well, we want to do this in this instance. Well, if you tell Simio you can go in and out of a contract, it's going to do it for the rest of the time. But you're saying that's almost like as required. So if that's within your realm for the next month, you do that. And Simio's not going to say the same result because you've taken it out of the control of the Simio software. So that's something you're always trying to manage, because people say, well, why Simio? Why is it not matched with Simio? Why is it different? Because you're not following a standard process. And we can put all these different caveats in. But remember, the more decisions that you put in there saying, well, if this happens, then we do this. But if it's this, it's this. That's not a standard process. That's not a sustainable process.
Yeah.
So that's one of the things that consistently happens, where we're reacting on the shop floor to something which we don't want to say is our standard process if we were to operate how we want to operate.
Okay.
So.
No, Brad, thank you. We unfortunately ran the clock down here. So great questions. Thanks for the great responses, and have a great rest of the day on your side. Thank you.
You too. Thank you.
Thanks, guys.
Bye-bye.